So now we're going to focus on probability sampling. Probability sampling is random sampling, like the simple random sampling you learned in statistics, but it's also about more complicated ones that have systematic ways of sampling until we get to eventually definitely a random sampling approach. So now we're just going to briefly review some of the things you learned in statistics and talk about some other things related to sampling error and the sample size you need. So random sampling uses chance to select people or elements, like drawing numbers from a hat, the stuff you learned about in statistics. And it's incredibly important. It's the foundation for all kinds of government statistics, unemployment in the labor force, air quality, and so on. It also has the advantage that it gives you methods for figuring out the precision, the size of the errors for certain types of quantitative results. I also want to highlight that you should not confuse random sampling and randomized experiments. We haven't learned about randomized experiments. We will do soon. You've probably heard about them, like randomized clinical trials, for example. All I want to say now is that these are totally different things. All they have in common is random. Something's randomized. Random sampling, randomly selecting elements from a population. That's important for descriptive research. Randomized experiments is going to be important for causal research. It's a little bit like what I tell students about how not to confuse standard errors and standard deviations. Just focus on the second word, error versus deviation. So sampling error. When you have a statistic from a simple random sample, it's an unbiased estimate for the parameter. So if you want to know the share of the labor force that is unemployed in the whole population of the labor force, we're going to take a sample. And the proportion unemployed in our sample is our best guess. And it's unbiased because the errors are going to average out to 0. But a random sample still has errors. Yes, if you took lots of them, it would come out to the truth in the population. But in any one sample, by the luck of the draw, it might be too much. Sampling error is the typical difference. So this sampling distribution shows you a lot of different samples and the results they're getting for the unemployment rate. But in a real study, we're just going to do one sample. So think about all the election polls we have now. A given poll is one sample and it has a result for, say 54% for Biden. Okay, now that is an error. Maybe by chance they got a few more Biden supporters, or by chance they got a few more Trump supporters than is true among all the voters. By looking at the theory of taking lots and lots of polls, you can get a sense of the typical error. That's the standard error. And as we'll see in a second, that's what drives the margin of error in all the polls that you see. So you use that typical error, that standard error, to construct a confidence interval, which is a formal statement of the precision. So the typical one is a 95% confidence interval, and it takes the actual result, like Biden 54%, and adds in both directions 2 standard errors, or to be precise, 1.96 standard errors, but it's about 2. And that becomes the margin of error, like plus or minus 3 percentage points. So Biden, for example, in a particular poll is at 54%. the margin is 3 percentage points. So that means we're roughly, it's a little more complicated. We have 95% confidence that the truth is going to be somewhere between 51% Biden and 57% Biden. So in the book, we have an example with support for birth control, and you want to practice interpreting them. A few points to notice: a poll or a survey will typically only give the margin of error for the whole poll, but it'll show subgroups. Subgroups are smaller, of course. They're subgroups. That means it's a smaller sample size. More sampling error. Wider confidence intervals, but they don't give them. So what do these margin of errors miss? They express only sampling error, not the kinds of errors we talked about in the last video or that we're really focused on now. They don't focus on coverage problems where the sampling frame is, right? So they don't focus on the fact that maybe Democrats move more often, so the area code means you're not getting as many Democrats who live in a particular state. They don't focus on non-response, whether different groups have less likelihood or more likelihood to answer the phone or agree to participate. Data entry mistakes. Fewer of that in our virtual world. Misinterpretation of questions, all these other things. So think about the latest poll you saw in the news. Maybe it's a state election one. Maybe it's a national election one. Think about what the errors in the stated margin of error miss. All of these worries about whether people's willingness to participate in a poll is related to their politics. So often when people want to implement a survey, they're worried about how to determine the sample size they need. And they want to know, how much is enough? Well, it depends. What does it depend on? Precision. How little sampling error desired? Are you happy with plus or minus 4 percentage points? Or do you really need plus or minus 2 percentage points? Is it a close race? How much analysis will we cut into subgroups? Because the subgroups are smaller, so they have higher sampling error because it depends on the subgroup size. Also, if you're thinking about how many people to go out and try and get in the first place, it depends on the response rate. The less response you have, the lower the observed sample size for any true sample, for any attempt to get at people. Often you have to guess your response rate. A few important points. The size of the population does not affect precision. So people often think, well, there's 300 million people there. How can you learn about them with a sample of 300? You might say, 300 might be okay if you're only interested in learning about a population of 3,000. Not true. The size of the sample determines the precision, and it doesn't matter whether you're trying to set a big population or a small one. Another thing is that if census is cheap and easy, think about those organizational surveys. Yes, we would like to survey all Marks graduate students. Do we sample? No, we just send an email with a link to everybody because it's cheap and easy to do a census. The word sample is used in different ways. I just talked about the true sample and the observed sample. The true sample is all the things that we learn the statistics about, those nice, pretty distributions, all the equations. That's the meaning in statistical theory. That's what the margin of errors really are about. But actually, that's not what people talk about when they have the observed. They talk about the observed sample, right? They talk about how many people actually answered the phone and did it. The problem is, that's only part of the initial randomly selected true sample. So maybe that margin of error formula we're using doesn't really apply in this case. Okay, so that's it for the sort of basics of probability sampling, really of simple random sampling. Next, we're going to turn to more complex forms of probability sampling. They always eventually get to simple random sampling, but we can do some more systematic things that also include sampling or describing a population before we get to that.